So, good day everyone. I would like to present to you the second paper that I choose entitled Flow-Mediated Coupling and Projectiles Falling Within a Super-Lead Granular Medium by Solano, Caballero Pacheco, and Ruiz. So, this paper is related to the paper that I presented last time, which is about cooperative dynamics of the penetration of a group of intruders in a granular medium, where the authors reported about the flow-mediated attraction between projectiles impacting in a granular medium. So in this paper, the author performed experiments and discrete elements of particle simulations to determine the range of action and the origin of the attractive and repulsive flow-mediated forces. So for the introduction of this paper, so when several objects move in a granular material, they affect each other's dynamics through interactions mediated by the grains of the medium. Or when several intruders impact side by side, they penetrate into the medium, presenting a bird flock-like cooperative dynamics. So as for example is as shown in this figure. So accordingly, the region that is affected by the movement of one intruder was found to be of the order of 6 times the size of the intruder. And by changing the initial separation of 5 impacting intruders, repulsive forces were detected only for separations smaller than 6 times the size of the grains, while attraction was observed for bigger separations. So, as based on the result by Pacheco and Ruiz that lateral repulsion is due to the jamming of grains between intruders, while attraction is due to a Bernoulli-like effects, or as for example is a pressure drop in the region between intruders due to a local fast flow. So in this paper, the author tried to determine if there exists a Bernoulli-like effect at the origin of the attractive force. So wherein they both performed experiments and simulation by varying initial separation of intruders, but exclusively with the case of 2 intruders. So for the experimental setup and measurements, the experimental setup consists of quasi-2-dimensional cell made by a pair of glass balls with an inner separation of 0.55 centimeters. So the cell is filled with a monolayer of polystyrene beads of diameter is equals to 0.52 meters and 0.52 centimeter and density of 0.014 gram per centimeter cube. So here is the schematic diagram of their experimental setup. So for the simulation model, so since the author performed a 2-dimensional discrete elements of particle simulations and using a different models of forces acting on the grains. As for example, in their simulation, they model a confining wall friction by adding a force F sub W on each particle that is proportional to the sum of the magnitude of its contact normal forces and directed in the opposite direction of its velocity. So this figure shows the experimental trajectories of 2 disks initially separated by separation distance is equals to 2.5 centimeters. So together with the trajectories obtained from simulation. So for the trajectories to obtain with the set of data label where mu sub f, or the coefficients of front and wall friction force, wall friction is equals to 0 and no air drag, as we can see in this graph that there is no attraction occurs, wherein the only considered here is the gravity and the contact force. So the set of data label for mu sub f is equals to 0.04 and no air drag. This shows that there is an attraction observed, wherein the that attraction is observed in these simulations, taking into the wall friction. So for the data label as 0.04 and there is an air drag, is the trajectories obtained with the complete force model presented in this equation. So as we can see in this graph that with this first model, the agreement with the experiment is excellence at separation distance is equals to 2.5 centimeter. So for their simulation setup, so they initially prepare 10 different granular beads, then put the two intruders 5 centimeter above the granular bead and separated by a distance. So is equals to, so iba-iba ang i-observe nila na separation distance. So here is the schematic diagram of their simulation. So each bead is prepared by random generation of the radius, initial separation, initial position, and initial velocity for each particle. For the diameters, a uniform dispersion of 6% is taken into account with an average diameter of 0.52 centimeters. So the initial position are randomly set inside a box centered in the simulation cell. So similarly, the velocities are randomly assigned from this range, from negative square root of the diameters times the gravity to positive square root of the diameter times the gravity. So and then letting the program run for 1.3 seconds using a step size of 2.76 microseconds. So for the case of 5 intruders, so this figure shows the snapshot of a simulation of the launching of 5 intruders. So as we can see that the simulation reproduced exactly the same behavior reported experimentally by Pacheco and Ruiz. So here is the result from the experimental of Pacheco and Ruiz. So back tayo sa figure. So for the first chains and first intruders, so same this graph or this figure also shows the simulation for the case of 2 intruders. So as we can see that this figure shows the position as a function of depth of 2 intruders with separation distance is equals x is equals to 0. So the middle, so same plotted also in the middle, the horizontal force of each intruder. So same result din yung lumabas sa simulation at saka sa experiment. So as we can see in this graph, which shows the total contact normal forces on each screen through the black color, which represents the larger forces, so which allow us to see very well the force chain. So for the Bernoulli-like effect, so they use simulation to measure the local flow velocity. They define a fringe limited by the upper edge of the uppermost intruder and the lower edge of the other intruder. So in this figure, so this fringe is divided into 30 cells, and the average velocity of rings is calculated using the beads located within each cell at each time step. So the velocity obtained for each cell and each step size in each time step is then averaged over 10 independent realizations, and the result is reported as the relative velocity with respect to the mean velocity of intruders at each time step. So this is the result, which shows the velocity profiles or magnitude obtained with the cell method. So for initial separation is equals to 0, 2, 5, and 7.5. So this represent that at impact there is no flow between intruders for x is equals to, hindi ko makita yung arrow, for x is equals to 0. So for the rest of initial separations, flow velocity is approximately equal in the region between the intruders and outside this region. So this corresponds to the repulsive regime. Once the projectiles depend through the bead, the velocity profiles change to be faster between the intruders. So it is during this regime when attraction exists. So mas ma-observe natin to during the sa video ng kanilang paper. So this result supports the idea that the origin of the attracting force could be a Bernoulli-like effect. So for the intruders velocity and attraction, this 6 graph shows the penetration velocity, the dashed line here, and horizontal force f of x as a function of d for the left intruder from simulation. So positive force means attraction, negative force means repulsion. So the gray vertical bands here shows an estimation of the part of the trajectory during which exists attraction. So as we can see in this graph, that there seems to be a correlation between attraction and penetration velocity being larger than 1 meter per second. So for the summary, so the authors perform experiments on discrete elements of particle simulations to determine the range of action and the origin of these attractive and repulsive flow-mediated forces, wherein they find that the drag force on these fluctuate with a characteristic length linked to force chains that build up and break. So the repulsive force is present when the separation of the intruder disk is less than 6 times the size of the grains of the granular bead, which is the size of an aperture that allows a continuous discharge flow from a container. So the attractive force has a range of action between 5 and 6 times the size of the intruder disk. So and attraction exists only when intruders move faster than 1 meter per second. So this result suggests that repulsion originates from jamming of grains between intruders, and it supports the idea that attraction could be due to a granular pressure drop in the region between intruders caused by a high flow velocity of grains, a Bernoulli-like effect. So that's all for my report.